All right. Good morning, everybody. We're just waiting for the last couple of people joining us for the Innovation Lab webinar series. Yep, I think that might be everybody. Hope you can all hear us. Apologies that all of the hosts have their cameras off. I'm afraid none of our internet is coping with us having cameras on, so it'll just have to be our voices this morning. But welcome to the Innovation Lab webinar series. This is the second webinar in this series where we're featuring innovative projects from the community energy sector. So around half the projects we'll be featuring in this series come from the Power to Change funded programme Next Generation, which we run here at the Centre for Sustainable Energy. But we're also really happy to be showcasing some fantastic innovation projects from the wider community energy sector too, such as the webinar we've got today from Gillian at Energy Local. So before I hand over to Gillian, I'm just going to do a really quick run through of Zoom for anyone who's not familiar. So just as a reminder to everyone, this session is being recorded and it will be hosted on our website afterwards, so please keep that in mind. It would be great if everyone could keep their microphones muted and their cameras off, and that's in the bottom hand corner of the screen. And if you can also see, there is the chat box at the bottom there highlighted. This is the preferred way that we'd like you to ask questions. And we also have Holly from Energy Local on the line, and she's ready to type any quick answers into the chat box as we go through the presentation with Gillian. Any that are not quick answers, more in-depth questions, we'll come to in the Q&A session, which Megan from CSE is going to lead for us at the end. And we're going to get through as many of those questions as possible. If you're having any difficulties hearing us or seeing the presentation, the best thing to do is select Megan from that drop-down list on the chat and send her a quick message, and she's going to try and help us with anyone who's having problems. You'll see there's also the participant list, and if you click on that, you'll see everyone who's on this webinar today. It would be great if you could right-click on yourself and rename so that you've got your name followed by your company. So it's easy to see who's asking questions when we come to the chat box. You'll also see the raise hand function on there. So if you're not able to type a question in the chat box and you'd rather press that to raise your hand, Megan will select you for asking a question later on in the Q&A session. So next slide, please, Gillian.
Yep, sorry.
Thank you. So back to today's webinar. We're really grateful to have Gillian from Energy Local who will be giving us a presentation today. That will be followed by a short interview from me, and then we'll be happy to take your questions. So without further ado, I'll pass on to Gillian at Energy Local.
Hi, good morning, everybody. So as Rich said, my name is Gillian Wright. I'm the Club Development Manager at Energy Local. This morning, I'm going to give you a very, very high level, very basic whistle-stop tour of Energy Local, and we'd really welcome any questions. If we don't cover it today, please do feel free to get in touch with me or Holly or one of our team afterwards. Okay, so here we go. So we are a community interest company, so that's not for profit. We are tiny. I think there are 4 of us, and none of us are part-time, none of us are full-time. So we're a very small, innovative company, and we're transforming the electricity market to support local communities and small-scale renewables. We work in partnership with all sorts of different organisations, from local authorities to community groups. We work with the National Trust. We work with all sorts of different types of groups. Right, but our vision is to help as many communities as possible get more value from the renewable energy that is generating in their neighbourhoods. By sharing that local generation, we can reduce people's household bills, we can help tackle fuel poverty, we can help give the renewable generators a fairer price, you know, now that there's a lot of the subsidies have gone, that's really important, and we can ultimately keep that financial benefit within the local community to help build stronger, fairer and more resilient communities. There are two types of clubs. I'm going to just focus on one today. If there is time at the end and anybody's interested, we can briefly touch on the other type. A low voltage generator can supply a low voltage consumer. So they have to both be at low voltage. So this would be a smallish, middle-sized renewable generator. Would be supplying households, small businesses, community centres, that sort of thing. So those people can form an energy local club. When you're looking at bigger generators that are 11 kV, some are even 33, that they can only supply people on that same consumption meter voltage. So you would be looking at, you know, things like a big industrial unit, might be 11 kV, maybe a big school, hospital. So it makes it a very different beast, if you like. One is very much about the community and the other is very much about business, and they are completely separate. But today, as I say, I'm only going to focus on the community ones for today. But you know, if you are interested, otherwise, please do get in touch. Okay, so how it works now. Mr. Windy Miller sells to big energy retail for 5 pence per kilowatt hour. That's your normal, what's called a power purchase agreement. If he owns it himself, he pockets all the cash. He can pay for his maintenance, gets his capital back over a few years. If it's shareholders, the money goes to shareholders. If it is a community-owned generator, then the community may benefit in some way. And then there's Mrs. Jones, who lives right next to this wind turbine, and she has to buy her energy from Bigley Energy Company at 14 pence per kilowatt hour. She gets no benefit from the turbine, and in fact she opposed it at planning because of that very fact. She didn't see the point, and why did she have to look at it? So with an energy local club, Windy Miller, Mrs. Jones and all Mrs. Jones' neighbours form a cooperative, which is the Energy Local Club. And what they do is they agree what's called a match price for the local generation. Now the match price is a number somewhere between the 5 pence that Windy Miller would have got with his normal power purchase agreement and the 14 pence that Mrs. Jones pays for her energy. So as an example here, we're just going to go for 8 pence. This is agreed by the cooperative. It's not dictated by anybody. That cooperative group of the generator and the consumers come up with this, they agree it. So the match price is the price of electricity when the club is using the generation. So if the wind turbine is generating at 12:05 and Mrs. Jones within that half hour is using power, she will get her share of that generation and she will pay 8 pence per kilowatt hour. So she pays 8 pence per kilowatt hour. Windy Miller will get 8 pence per kilowatt hour. So both are benefiting from having this match price. Oh. So with an energy local club, Windy Miller gets 8 pence per kilowatt hour for the matched. Anything that's not matched in the club, so he's generating but it's not being used, he would get it as normal power purchase agreement at 5 pence per kilowatt hour. So it just is the way it was before, but now he can get more for what he's generating when he's generating it. And this bill is what is not used within the club. That's the term for that. Mrs. Jones, she can buy matched at 8 pence per kilowatt hour. So if she uses power when the generator is generating, she gets that really nice price. Anything else that she buys, she'll get from Octopus, who are our current technical partners in developing this model. And we've worked with them to get a time of use tariff, so it's different times throughout the day to help people shift their load and change their behaviours. And so the benefits to this, for Windy Miller, he increases his income. he hopefully spends that extra money in the local economy. He may reinvest in more renewables because he gets a faster return on his investment. So it might help if he was thinking about putting in more renewables. He might think actually that's a better business case than it had been before. For Mrs. Jones, she reduces her energy bills. If she is in fuel poverty, it can help alleviate that. She will hopefully change her behaviour to use power at different times and just be more aware of how much power she's using. And because the partners at Octopus only have renewables for electricity, she sort of by stealth almost becomes 100% renewable energy consumer. And she is also supporting local renewables, and hopefully she's got more money in her pocket to spend in the local economy. So as you can see, there's quite a lot of benefits. So how it works. Wendy Miller has to move his power purchase agreement to Octopus. Mrs. Jones moves her electricity supply to Octopus. So they both have to be with the same company. And as I said, at the moment, we're working with Octopus to develop this. Wendy Miller has half-hourly metering. So does Mrs. Jones. So every half hour, it can be balanced and settled that, you know, however much is generated and however much is used can be calculated. Octopus settle half-hour blocks, what's calculated in the club and what's the spill for Wendy Miller. And likewise for Mrs. Jones, they'll say, well, this is how much is from the club match, and this is how much is from your time of use tariff. Mrs. Jones is given an online dashboard, which I'll show you in a second, which tells her when is a good time to use power, and it shows her patterns of use, which helps her understand what she's using and when. And then, of course, Octopus will calculate the bills and the remittance and do all the financial stuff. So there's no money exchanging hands between Wendy Miller and Mrs. Jones. It's all done via a licensed supplier. Okay, so this is the dashboard. This is an example from Bethesda in North Wales. This particular one, as you can see, is hydro. This was quite a rainy time here. This was February. So you can see here, if you look over to the side there, that whether it's not raining, you can see the blue line dips. And this yellow, amber, green shows when people are actually buying power from Octopus because there's not enough generation to cover the club. But for most of the rest of the time, in this particular instance, the hydro is amply sufficient for each of those half-hour blocks. So each one of these blocks is half an hour. At the top here, you'll see it says, now is a good time to use electricity until 4 o'clock. So it's telling you that it's a good time. So this software pulls in what's called a demand shaper, so it looks at what they think you will be using. It pulls in data from the generator and sort of uses artificial intelligence to help you make decisions, good decisions about when to use power. You can see this on our website. It's live. You can go and have a look at it. It's quite interesting. You can click around and change it to month and year, and you can see when it's not raining and all that kind of stuff. So yeah, it's quite a useful piece of behaviour change software if people are interested in that side of things, obviously. So how we, behind the scenes, think about setting up a new club. We have to think about what area does the club cover, and it's basically based on the primary sub-meter for that area. So if a generator is on the same primary sub-meter and on the distribution network, then anybody on the same voltage on that sub-meter can be considered to join the club. Obviously, there's only so much renewable energy available, so we have to make a sort of balance about how many houses or businesses or community centres should my club have, and we have a model that does, you can play around with the house numbers and the match price to see who benefits the best, and that calculates how much each house is like to benefit and how much the generators are going to benefit. And so you can come around with sort of different scenarios, and this is a very brief version of that. So it shows the different generation down this left there. And then we're playing around with the number of households and the match price. And we see who's get the best benefits between the generator and the houses. And, you know, for, you know, if it's a private generator, you probably don't want them to be laughing all the way to the bank. Well, with the, you know, but you've also got to make it quite nice for the householder to be willing to sign up. So there's a sort of there's a balancing act there, and it's very much dependent on the local demographics and who owns the turbine, and you know who are the beneficiaries at the end. You know, if it's a community owned, you know, building, then you maybe would want them to benefit more. So it just helps sort of formulate your plans. To set these up, as I said, we're a very small company, and things like Energy Local have to be driven by local people who understand, you know, what groups and how the community operates. We can't turn up to your town or village and say, hey, we're going to do this to you. So what we do is we work with local organisations who will identify somebody who could be a club advisor. Now, this person will be good at local engagement and have a lot of local knowledge. We train them, and we work with the local partners with them, and we support them in setting up the club. We help them do the modelling that we just talked about, looking at the number of houses versus the match price, and we help them try and find more renewable energy to bring in, so that, you know, they can recruit those generators. And then we also help them recruit members into the club, which is quite important, and that's a really big part of it, is to do all that engagement stuff. And then the last piece is each co-op has to be registered with the FCA, so we help them through that process as well. And so they're usually maybe 10 to 20 non-consecutive days of work to get to the setting up of the club. And then after that, the club should be self-sufficient. Our role is obviously training the advisor. We provide them with a toolkit to help them with their engagement plans and their site assessments and all those sorts of things. Our website provides a dedicated page for each club, and then the back of the website has a secure members portal where members can register their interest, they can put in their details, they can say they want to switch to Octopus, and that's also used, you know, if we need to send out communications and things like that, that is the sort of database, if you like, for that. We provide back office admin for all the transfers with the licensed supplier, which is Octopus in this case. So we do a lot of sort of really making sure that all the minutiae of detail and all the different steps that happens in the background are carried out for each club. We request a time of use tariff from them. These are bespoke for Energy Local. They are done by DNO area and by club, so they're not available otherwise to other people. We sponsor the co-op constitution, which makes it much cheaper to form a co-op and easier. I think it's about £40 rather than going through a legal process, which could be hundreds or thousands. And then, of course, we provide that dashboard ongoing, so that as long as you're in an Energy Local Club, you can access that dashboard that I showed you earlier. And the co-op, I'm sure a lot of you are very familiar with the co-op structure. Each club is a co-op. It's just to maintain fairness between the generator and the consumers, really. They'll agree the match price annually at their AGM. The board members have to have members from the generator and the consumers to keep that fairness. They might decide on development changes for the club. You know, one of our clubs is looking at a phase 2, and part of the co-op's role is to decide who they're going to target in phase 2, because they really feel that maybe people in fuel poverty or certain particular geographical areas, you know, could benefit from it. And as I said, the board should be self-sustaining once it's set up. Okay, so I'm just conscious of the time. So with the Energy Local Club, I mentioned behaviour change earlier. Some people will just join the club, that's it, not even look at the dashboard, and they will make some money, and that's how we base our model. But nobody changes what they do, so our model is very conservative. But then you'll get people who'll look at the live dashboard and sort of play around with things and think about the time of use tariff. And when's the best time to, you know, put on their slow cooker or charge their laptop or whatever. And then there's people who might adopt sort of Internet of Things, you know, with smart plugs that you schedule. And we do have another project, which I won't go into today, where we're looking at synergizing those with our dashboard so it can optimize things. But if you're interested in that, you can obviously contact me at a different time. And there'll be people who sustain those behaviour changes. There'll be people that will do them for a couple of weeks and then go back to normal. And then there'll be people who become a committee member, a volunteer, and absolute ambassador for the Energy Local model. So there's lots of different levels of engagement, and we know everybody's different. So yeah, so that's a very whizzy overview. So just in summary, the Energy Local Club can help match renewable supply and demand locally. It can improve renewable energy paybacks and possibly even make something that's not feasible, make it feasible. Improve the local economy, alleviate fuel poverty, hopefully increase social cohesion, because people are sort of working together and learning peer-to-peer about energy saving and shifting behaviours. Like I just said, change behaviours to save and shift energy use, and hopefully make renewables benefit more of the community. So, and these are my details. I'm sure you'll be able to get them from Rachel afterwards. And please do get in touch if you have any other questions, or if you have ideas for a club that you want to talk through. These are my details. So.
Thank you very much, Gillian. That was really, really interesting. There's lots and lots of questions coming up.
Oh gosh, sorry.
We'll give Megan and Holly a little bit more time to be answering those while we have a little interview, and then we'll come to those. So keep adding your questions to the chat if you've got any more. Okay, so first one of my questions. So where did the need for your project originate?
I wasn't involved originally. So Mary Gilly is our director, now I'm going to get this wrong, of innovation and technology, or it could be the other way around. So this was her brainchild, really. And well, I think there's several parts, really. I think the incentives for renewables has decreased, obviously, making them not viable financially is one. The fact that people aren't benefiting, like I said, from something that they're having to look at is two. But something I didn't really mention in the presentation, that actually, you know, we've recently seen the issues when you know, consumption demand has plummeted really, you know, overnight. and the grid just can't cope. But if we were balancing that grid more locally, so using this local power at the time it's been generated, it could actually help the overall network as well. So there's some sort of behaviour change and sort of benefits to the communities, but also from a sort of national infrastructure point of view, shifting people's behaviours to the cheaper time of days. Even just doing that, helps the grid overall, which must be a good thing.
Yeah, definitely. Okay, so who are your key partners in this project?
Well, as I said, we're working with Octopus Energy as the licensed supplier. So they are sort of doing the technical, we know that this works, but they're having to sort of work through how do we integrate this with the billing systems and the metering systems and the data collection systems and all these things that happen that you don't even know about behind the scene. Your bill arrives for your electricity and you don't even know half the stuff that's happened, to get it to that point. So they're a key partner. Megni is a small innovation company, and they've developed the dashboard and still develop dashboard. They're also doing all the smart plugs and how to control them. We're actually testing some of them now. I believe mine's in the post to test. So they're a key partner. Who else? We have lots of funders. Obviously, as a community interest company, we have to spend a lot of time writing bids and things. But our main partners, although they're not across the country, national, if you like, our local energy groups or community groups, all the ones who've had this idea to start an energy local club, and those community champion people that are really passionate about their community. We couldn't do it without that engagement with them.
Yeah, definitely.
I don't know, I'm just wondering if Holly's there, if I've missed anybody. Sorry, she's probably busy typing.
I think you covered everyone.
Did I? Thanks, Holly.
We also do research projects. So we're doing a research project with Scottish Power Energy Networks and De Montfort University. And also we work with the Department of Business, Energy and Industrial Strategy on specific funded projects. And organisations like Connected Response, who do the... Oh, sorry, you've mentioned them.
No, I didn't. No, I didn't.
Oh,
no, I
okay.
didn't.
Okay, Connected Response, who have a sort of consumer unit that communicates the data from smart meter to the customers into the dashboard. So
it makes it like a live feed, doesn't it? That's
exactly.
Yeah, I think that's So some of them are technical partners, some of them are sort of on the ground delivery partners, and with BAYS, obviously they've got a wider agenda and we're sort of delivering some innovation for them.
Yeah. So I was just wondering, with your partnership with Octopus, how did that come about, and is there something that's specific about Octopus that's different from other energy companies that makes this work as a good partnership?
I don't know how it came about. It was before my time, to be honest. We were with Octopus before, but obviously Octopus Retail is now part of Co-op. We were with Co-op before, and now Co-op Retail is part of Octopus. So it probably felt like a natural thing. But I think, from what I understand, the choice to go with Octopus for this was because they had a really good platform for dealing with all of the billing and data flows and what have you. I mean, I worked in retail quite some time ago now, but there was like 6 or 7 different systems that didn't speak to each other. You know, you had the application system, and you had the metering system, and you had the billing system. So I think with theirs, it's all encompassed and all in one, and so it synergizes better. But also they do have that ethos of innovation, as you probably know. They have lots of these really unusual tariffs. You know, if you have an electric car, you can get a special tariff. You can have an agile tariff that changes throughout the day. You know, who would have thought we'd have get that in domestic houses, you know. So yeah, so they've got that ethos, and they've also got that renewable energy, that all their power is renewable energy. And I think they do want to change how the electricity industry is not perceived, is delivered, because it is so old and clunky and complicated. I think they just want to push the envelope a bit. So I presume that's why. That's my opinion. It could be wrong. I'm sure Mary might tell you something different. But
Great. Sorry, next question. What social impact do you aim to have, or are you already having?
Well, I think what's quite lovely about this particular project is it does tick all, you know, your sustainability, sustainable development boxes. You know, because it helps people financially, it helps generators financially. You know, it could result in more renewables if, you know, people thought that the business case then stacked up. So that from an environmental point of view, you know, so you know, and then obviously that would helps the community if there's more money in the community as well. And so, I mean, and even just by doing that balancing locally, it means that there aren't so many losses on the network, you know, and getting people to shift to use the power at the right time and all that kind of stuff. So I think it's kind of one of those unusual models that it does, excuse me, the whole sustainable development triangle, you know, the three P's. So yeah, so I think from a social point of view, it saves people money, and then it also brings communities together, because they've got to form this co-op and learn together of how to share behaviours.
Yeah, definitely. So as well as social impact, what environmental impact do you aim to have, or are you already having?
Well, like I said, I mean, if you think about it, if we're just linking up to an existing renewable energy generator, you know, we can't really say, oh, we're saved all this carbon. However, you know, if that generator then, you know, gets a better payback on that particular, I don't know, hydro, and then decides to build a wind turbine or put PV on because of that, you know, then it can lead to that. I think it will help people become more aware of what they're using and when. So that behaviour change, and like I said, you know, with those lists of engagement, you know, some people will just switch to the club and not even think about it, but some will get really involved and really interested, and might even lead to other sort of environmental or social interests. So yeah, I think, yeah, it's sort of tenuous, but I think it's quite strong at the same time. It's kind of this odd dichotomy, really. Yeah, I think the behaviour change thing is quite powerful, and also bringing people together like that to work together, I think, can be quite good for other, you know, it's sort of more of a social environment, if you know what I mean, as well. You know, like community spirit and all that kind of stuff. So.
Yeah, no, I think you're right. I think a general awareness of what your local environment is providing you with,
yeah,
is quite a big sort of environmental and social benefit. The fact that you don't just see your energy as something that is coming from far away. It's provided to you locally, just the same way that a lot of other things are, like the parks and the green spaces are. And hopefully it does increase your awareness of everything that you're gaining from your environment.
Yeah, I mean, eventually we'd love to add it to the shop local kind of ethos, you know. But I think we're a bit far off that yet. But you know, don't just buy your potatoes from the farmer. You know, get your power from him as well.
Yeah, sounds great. So obviously Energy Local already is being replicated in different areas of the country. So if someone on this call were interested in being a part of that, what's the sort of things they need to consider first?
I think there's a couple of things. It's got to be led by the community. Like I said earlier, we can't come into a community and just rock up and say, hey, we're going to do this. You know, it's got to be led from the community. So it's sort of identifying those sort of groups or people that might be the types, you know, those the community champion types. Obviously you've got to have some generation or have plans to put in some generation, because we're not really in the business of helping people write feasibilities, because we've got enough work to do already and there's only a few of us. Although we have, you know, done some work with, you know, seeing how you can help the Energy Local model with, you know, if you were bidding for money to install renewables, because this helps the feasibility, obviously. So yeah, I would say check if you've got a generation, first of all. Remember that low voltage rule. That's a key question. And then just give me a call and we can chat through. That's really the first thing to do.
Great. And last question from me. What are the key lessons learned that you think other people should know?
Be patient. Innovation could take longer than you think. Some communities mobilise very quickly and others don't. I think you've got to be very mindful of that psychology around early adopters and people who kind of wait to see what other people are doing first. So I think with Energy Local, it's quite nice to start small and then build up. So you then give more people an opportunity to join, because the portal I talked about actually timestamps when people register their interest, and we tend to go in a first come first serve. So if you modelled, say you've got a turbine and you're like, right, I can get 30 houses on that turbine, and then you get 40 people, who do you pick is going to be in the club? And also, when somebody's in a club, they're not likely to leave because it's quite a good deal. So then it's kind of discriminatory against the people who didn't get that first bite of the cherry, or who were a bit cautious, or just don't have that ability to risk their finances, you know. So if you can start small and then, you know, add in more generation or maybe just limit it to start with, I think that's quite important as well. I'm sure I had something else to say, but I've forgotten. If it comes back, I'll let you know.
That was great. Thank you very much. I can still see lots of questions coming from the chat. So Megan, are you happy to take those forward now?
Yes, hello. Loads of questions. Holly has been answering some of these, so I've just been collating them and checking which ones she's answered. Okay, so got a question. So I'm going to take it by order of the questions asked and the timing of the questions. I've tried to categorize them as best I can, but here we go. So a question from Will Houghton. Commercial and domestic consumers may be paying different prices for their electricity. Would Octopus allow different consumers to have different tariff rates?
Yeah, what we've agreed with Octopus is that households will get that bespoke time of use tariff that we mentioned earlier, but business customers or commercial will just get the normal Octopus commercial and then get the sort of added bonus of the match when the match is available. We had hoped to do it differently, but it's far too complicated and very onerous because there's so many commercial tariffs and there's so many different DNO areas, and that's how the tariffs are kind of calculated. So that's what we're going to be working with. The commercial customer still has to have a half-hourly meter though, of course, to match up to the generation. So just to make you aware of that.
Another question about Octopus from Philippa Purchase from Transition Bude. Talking to Energy Local Bridport, they say the software from Octopus isn't ready yet. Any news on when this will be available?
Oh, yeah. like I say, we are still working on it. We're inching closer. We're hoping it'll be the next couple of months.
Okay.
But please, yeah. But like I say, this is what I say, be patient. Everything takes longer than and I don't want to use it as a cop-out that it's extremely complicated, but it is extremely complicated. Yeah, but we are working really hard to get it there, and we know it can be done, and they're committed to getting it done. So, yeah.
Okay.
Watch
this space.
Yes, exactly that. You'll see all the cheering when it comes through. Like, yay!
We've got a couple of questions from Jethro on the live feed device. So which live feed device is used, and does the data flow go through the DCC SMETs or with this live feed device?
It's made by corrective response, Holly? Corrective response. Connective response, that's it. That was wrong. And it's basically just a little box which is wired into your smart meter, and that data goes to the dashboard. I don't think it goes through the DCC. I think just the smart meter data goes through the DCC, and the CAD goes to the dashboard because it sits on a different network, I think. I can find out for you. I'll make a note.
Okay, I just seen that the question about local councils was answered by you, Holly, so thank you. Got a few questions about generators. So from Steve Ashton, how large does a generation system need to be considered worthwhile to set up a club? We have a 50 kilowatt PV here.
What type of meter does it have is the question there. If it's got a 3-phase import-export, that's fine. A rule of thumb when setting up a club is that 1 kilowatt generation, and obviously it varies because there's so many different types of generation, but 1 kilowatt generation would be like a house. But as part of the metering arrangement that we have to set up in the background, which I didn't go into because it's quite dull and complicated, we need a 3-phase import and export meter. So generally, I would imagine a 50 would have that, but it's not consistent because of locality and stuff. So that would be your key question there.
Just to chip in there, it's also the voltage level at which the generator is connected is also relevant. Which I would be very surprised if a 50 kilowatt was not connected at low voltage, so that should be okay because consumers will also be connected at low voltage.
And a question from Mary Anderson at CAG Consultants. Do any of your clubs have multiple generators?
Yes. So they can have multiple generators, and they can have multiple generation types. So we could have a mixture of wind and solar. It's actually quite good to have a mixture of types because, you know, solar, summer, daytime, hydro could be constant, could be more winter, depending on, you know, how it's commissioned. So yes, in answer to your question.
And from Guy Hopwood, so they have a larger generator here. So we operate a 500 kilowatt community wind turbine. What type of club can we supply power to?
So it's got an echo. It depends. Again, like Holly just said, what voltage it's connected at. That would probably be 11, I would imagine. In which case, you would be looking for consumers who take off and are metered at 11. So it could be like industrial units, a big school. You know, maybe there's some manufacturing plants on the same substation. It's a bit trickier, that one, to be honest.
From David Saunders, Lockleys Love Solar. Can we do this matching a group of people with solar roofs as a single virtual generator with a group of people in the same or who don't have solar roofs?
That's an interesting question. So we do need one of the generators to have that three-phase supply. So that generally means it would be a slightly bigger generator or an installation on a bigger building. So for example, where I live, there's a church at the top of the road which doesn't have that big a PV array, but it's got a three-phase meter. So we could use that as the sort of the nucleus, and then at some point in the future, we're not quite there yet with it, we will be able to add on domestic to that or small scale, but at the moment we're not quite there yet. But we do need that big meter, three-phase meter, to sort of be the glue, if you like, that holds them all. That's the sort of the centre of the web, if you like, that holds them all together.
Okay, thank you. A question from Karen Smith saying, if there is no local generator, you'd need to know if there are other generating households, community organisations within the substation area. But how does this pan out regarding community benefit or and having enough local energy generated to go around?
Sorry, so there's no generation, or there is generation?
So if there is no local generator, you'd need to know if there are other generating households, community organisations within the substation area. So you need to know this for marketing and to get people involved in the Energy Local Club. But how does this pan out regarding community benefit and having enough local energy generated to go around?
Okay, well, I mean, unfortunately, if there's no generation in the area, there's not a project there. But what that lead organisation can do is we can use that, we would train that advisor, and they would be able to look at the DNO's mapping portals. Some are better than others, I have to say, to try and identify generators and approach them to see, you know, if they would be interested or if they're able to, you know, join the club. I mean, it might be that they use all their power already, you know, if they're quite smart. That's how we used to, back in the olden days, that's how I certainly used to design renewable installations. So I think if there's no renewables in the area, then there's none. But this is why we use local advisors, so that they can go out and find these generators. But also that you can map on the DNO what the substation area is, so you know what, if you're in a rural area, what villages you're looking at, or in a city, what kind of zones are fed off. And then the community benefit, like I said, of that modelling tool that we have, you can put in how much generation you've got, and then you can play around with the number of houses and businesses that you want, or you think you might be able to get in the club, and then that gives you the potential financial benefit.
Okay. Thank you. So we've got a few questions about Ofgem. So one question from David Saunders: how does the club manage to avoid energy transmission charges? Is this model infinitely extensible, or will Ofgem and the DNOs crack down?
Well, we work very closely with the DNOs, and they actually want this kind of thing because of doing that balancing locally, it actually helps them out. So there's nothing, I don't know, Holly might have more.
Yeah, so specifically with the DNOs, currently the agreement is that we will pay the distribution charges, Octopus will pay the distribution charges, the DUOS it's referred to, as they would normally. What we would like to get to the point of would be having a bespoke DUOS. So that would be a bespoke network charge that reflects the fact that although the electricity is using the distribution network, it is only travelling a very small distance on that network, and therefore the electricity supplier should be rewarded for that, and subsequently the customers. This is innovative, as Gillian said, and we've worked Ofgem are aware of what we're doing, and as are Elexon, who manage the balancing and settlement code. And they're also looking at lots of different ways of how the market can be more flexible. So I'd say sort of watch this space, because I think Energy Local needs to be seen within that broader context of a move towards a flexible energy market. And we don't know what they will do to help that direction and what they might do to make it more difficult. But yeah, so far everyone's aware of what we're doing, and it's fine.
Okay, question from Richard Hoggett, Uni of Exeter. Does this approach require derogation from Ofgem, or is it covered under the license output hold?
Yeah, no specific derogations required.
Okay. A question from Tim Baldwin on batteries. Have you tried to incorporate batteries into the system, either domestic or larger scale?
Not as yet. However, we are looking at potential research. Well, not really research. Development funding to trial that out. So not yet, but we have it on our radar.
And a question from Julie Phillips. Can an existing community interest company create an Energy Local Club as a project running alongside other projects?
Of course, yeah, absolutely. There still has to be that cooperative, and we understand that does sound laborious and overly bureaucratic, but it just identifies those people who are in the Energy Local Club, and it can be very administratively, as minimal as you want. You could do half-hour a year to go AGM, yeah, okay, done. So, and put your accounts into FCA, but it can't, yeah, it runs alongside all sorts of different organisations. Like I said earlier, we have partners with community energy companies and, local authorities. It's fine.
How many Energy Local Clubs are actually operating now? Question from Guy Hopwood.
Currently, none. Because we swapped from Octopus, we're still setting up the back office stuff with Octopus, but we're very close to getting it. So we've got, I think, 5 that are just on the brink of opening. So once they're done and everything's good, then we're going to be exceedingly busy getting new ones off the ground. So yeah, it's like I said earlier, it has taken a long time for Octopus to work through all the different issues with the background flows and what have you. But we have had one, as I said, we have had one working with Co-op when it was with Octopus, so we know it's possible. And as I say, Octopus are committed to delivering. So yeah.
And a question from Peter Boate. Do all the members of a club have to be on the same low voltage transformer? Not clear what was meant earlier by the primary submeter.
So the primary submeter is on the distribution network, so it would be owned by whoever your DNO is in your particular area. And that tends to have several feeders and sub-stations, if you like, that come off it. So I don't know, I'm not sure what your background is to be able to understand. If you can get on the mapping system for your local DNO, you can trace from your generator back to the primary and then out to see what your area is. So if you looked at like a rural area in Wales where I've done quite a bit of mapping, sometimes it can go for 10 miles, but then in a city it's sort of more condensed, but it's kind of sprawls in a very strange direction. So it can be actually quite difficult to communicate what area is in and what's out.
I'm going to skip a few questions just because we're talking about the low voltage network,
Okay.
and there's been a few questions about that. Guy Hopwood's just asking, the issue of connection voltage is confusing and unclear. Do you have any information which clearly explains this? And another question from Steve Ashton just saying, I'm unclear about the low voltage requirement. Even our 50 kilowatt PV is connected by an 11 kilovolt PMT. Does that preclude us from considering a domestic club?
Yes, at the moment, yes, it does. It's not to do with the physics of how electricity moves around. It's to do with how the utility company do the settlement. So it's actually just an accident of numbers, really, that only a low voltage generator can supply a low voltage consumer with this model. So likewise, an 11 kV has to supply 11. We are hopefully going to try and get that changed, but as you know, these things will take a very long time. But at the moment, that's how it is. So you just, the metering of the generator has to match the metering of whoever it is supplying within the club.
A question from Paul Fair from Energy for All. What evidence have you collected from communities that show there is a demand for energy local?
We've got, I think, about 900 people on our expressions of interest list, maybe not quite as many as that. I think we've got probably 12 or 13 clubs that are ready and waiting to go. Our club, I think somebody from Bude mentioned Bridport, which is in Dorset. They opened their expressions of interest on our portal, and I think it was 3 days they were oversubscribed. So I think, yeah, there's definitely a demand. People want to save money. I mean, people want to save money. People want to help the environment. They might not want to do both, but they might, if they would want one of them, you know, it'll be for them. Some people like whizzy technology numbers. I think that like I was saying earlier, what we need to be careful of is not leaving behind people who aren't the early adopters, who probably would benefit more. You know, so people in fuel poverty, vulnerable people, you know, maybe elderly or whatever. I think we need to be conscious that they get a bite of it too.
Thank you. A question from Paul Darlow. Young Community Energy have solar farms only. Presumably a consumer can only buy electricity at certain times of the day and on the day itself, say if it's raining hard at midday and high demand, no availability.
Yeah. So by saying the word farm there, I would assume that it's quite big and probably on a higher voltage than you would be selling to houses, but that's just an assumption. Yeah, so everybody's metered. The generator and the households are metered every half hour. If the generator is not making anything in that half hour, then the consumer would just buy like they would now from the utility company. If the generator is generating, then whatever it's generated is split evenly between whoever's consuming at that time.
A question from Mary Anderson from CAG Consultants on impact. How is the impact of energy local clubs on consumer behaviour change currently being monitored or researched?
That's quite interesting. Because it's still quite new, we've not done that, but we are going to do that. So, and I do know that the work that De Montfort University are doing for us will look at how much people do change the behaviour and how much that behaviour change actually sticks and doesn't kind of, you know, slip back to how it was before. You know, does the dashboard become wallpaper? So we're not quite there to have results yet, but we will be doing that. And we do also, once a club is set up, we sort of do surveys and under normal circumstances, have community events to try and get feedback and get them to learn peer-to-peer. It's like, well, I do this, well, I don't do this, and share tips, top tips and things like that as well.
Question from Sam Parkinson from FX or Westmill Solar Co-op. How many households can be involved as part of the club?
Depends on the size of the generation. Like I said earlier, we would go on a rule of thumb, very roughly, that 1 kilowatt generated is one house.
Question from Mark Staden, Community Energy Plus. When can we find out about the 11 kilovolt version of the model? What's the development timeline for this?
We do already do the 11 one. I just didn't focus on it today. So basically, an 11 generator, you would need to find some demand that's at 11 kV, like I said. So it would need to be industrial units or something that's pulling off that higher voltage, and then we can work with you to set that up. We've already got some of those going.
Another question from Young Community Energy. So from Peter Brown, we Young Community Energy produce more than 12 megawatts. Would we have to have a PPA with Octopus in order to get our local electricity sold to the local community? Will the local energy bill allow us to sell direct to community, or will we always have to do so via an energy company such as Octopus?
We don't know what's going to come out of the local electricity bill. I know that they're looking for people to sell directly. Personally, this is my personal opinion, I think that's really risky getting into that. We've seen quite a lot of small electricity and energy companies going under recently because they can't handle the cash flow. So using a regulated licensed supplier, kind of, they go through all that pain for you. But like I say, that's just my personal opinion. The PPA and the consumers have to be with the same company. At the moment, we only work with Octopus because this is a development innovative project. In the future, we may work with we would love to work with other companies as well, and to give people more choice and flexibility. But all of the club has to be on the same supplier. That's part of the thing. And you mentioned 12. Was it megawatts, did you say?
Yeah.
Yeah, that sounds like it's probably high voltage. Unless it's separate generators, probably.
Okay, and sort of going back to the previous question a few questions ago about the kind of the nature of solar energy and the times of the day. We've got a question from Chris Stewart Bennett from Low Carbon Gordano, asking that given that PV generation is generally in major decline by 4 p.m, when the Octopus time of use tariff price hits its highest levels, do you really think that this model is viable for PV from a consumer's point of view?
It is. It's not. PV is not as good as other renewables, which is a shame because it's very prevalent, obviously. But that's where the behaviour change stuff would hopefully come in, where people are able to, they can shift their consumption. And so part of the project that I touched on with the demand side response and using smart controls and things could help that. But yeah, you're right. And that's why I was saying earlier, it's really nice to have a mixture of generation in your club if you can, to balance out, because solar is so very limited. I mean, it would probably be great for places that, just have, summer, businesses that just run in the summer and things like that. Yeah, but places like, so where we've got like, say hydro that is continuous and runs all night. We've had, we've looked at putting households on, but then we've also looked for industrial or smaller industrial processes that run at night. So things like maybe a dairy or a bakery or things to try and, use up what's being used when the households just can't. So yeah, you're right, but there still is a benefit. It's just not as great as it would be if it was more continuous.
Okay, and going back to the kind of the network, low voltage and high voltage. Question from Guy Hopwood, Grinnell Community Energy. The Bethesda Hydro is 100 kilowatts and must be connected at 11,000 volts. How can this supply a domestic energy local club, but our 500 kilowatt turbine couldn't?
I'll leave that to Holly because she's the advisor for Bethesda.
Yeah, actually, the Bethesda is actually connected at low voltage. I think it's quite random sometimes.
Quite unusual, isn't it? Yeah.
What gets connected at high voltage and what gets connected at low voltage. And it may be that because, I don't know where you're based, but in areas where there's like the amount of connections already on the network will affect where new generators get connected. It's also some places are sort of, to be honest, I don't know the details of this, but they can have a certain connection, but then they actually output at a different level. So if you've got a specific question about that, I can find out more, because I know that it's not there is some things where it's under one measurement it appears to be LV, and another measurement and another it appears to be 11 kV. I don't know the technical details, but yeah, if you contact me directly, I can.
Yeah, and I think just going back to that, it's not consistent across the country. It sort of depends on the local infrastructure. If you look at some of the Scottish Highlands and Islands, it's, you know, they only have 33 connections, which are then transformed down, obviously. They just don't have an 11 kV network in some parts of the outer islands. So yeah, so that's why we always, the first instance, have to ask these questions, because there aren't hard and fast rules really with that.
A couple questions from Jethro. If distribution charges are being paid, how much profit actually goes to the generators? And can a complex site agreement be used to avoid these charges?
Holly. Sorry.
Yes, well, yes and no. The reason why we are, the arrangement is that the distribution network charges are paid is actually something that we've done proactively, because we don't want to be seen to be avoiding charges for things that we're using. So although yes, we could avoid them in the sense, we've actually contacted the DNOs to say we are not, we don't think we should, but we do think we should be paying less. So for the time being, placeholder, we will pay via, we'll pay the distribution charges. In the long run, we think the distribution charges need to be changed to reflect this local balancing. And in terms of the profit, so the generator will still get the benefit. Obviously, it's the supplier who actually will pay the distribution charges, and they can choose to recoup that via either a slightly higher PPA price for the generator, or a slightly a slightly lower price for the generator, or a standing charge, or a little bit extra on the time of use tariff. That's up to them in their pricing team as to how they would do that. It still works out that the generators should be saving money, but yeah, the details will vary club to club and go on specific tariff.
Yeah, and the other point is that we do use the complex site model. That is what we are doing. already.
Okay, and coming on to the final submitted question in the chat box now, from Philippa Purchase, can you give us an idea of your charges for training and club setup?
Yeah, I mean, it does vary because, you know, so in November we did quite a few clubs down in, where did we go? Bridport in Dorset. So obviously at those times we were allowed to travel around the country and work, whereas now we would have to do it online. So usually to train an advisor and set up the club, I think we would, again, depending on sort of the number of people and the type of organisation, it's usually between £3,000 to £5,000, depending on quite a lot of variables for us. But then, of course, whoever is doing being the advisor, somebody needs to pay them as well. So quite a lot of our clubs would go for local funding to help support that.
So we've got still some time for questions. So I guess if anybody wants to type them in the chat box, or you can also raise your hand and I can unmute you. Yeah, we've got about, what is it, 20 minutes or so? Give it some time.
Yeah, we've got about sort of 10-15 minutes if anybody would like to ask another question. I did see a few hands raised at the beginning, but I think they've gone back down, so perhaps they type them in the chat box. Just give sort of 2 minutes if anyone more questions come through. I can see another one.
If you are paying the distribution charges, what is the purpose of the complex site? From Jeffrey.
Well, the complex site still is what links the meters together, and that's how we can incentivise the local balancing.
So a complex site wouldn't necessarily remove the need for those charges then?
Well, it removes some things, like it removes the balancing, some of the balancing charges, but obviously as the balancing is done locally, it's not needed.
Okay. Yeah, so there's some reduction in transmission, but not completely.
Great. Well, I think that's all of the questions then.
Okay.
Thank you so much, Gillian and Holly, for answering all those questions.
Pleasure.
If anyone does have any more, Gillian shared her email address earlier, and we will be sharing a recording of this, so you can find it on there. But you're also welcome to email the Next Generation inbox, and I can pass on any questions to Gillian. But yeah, thank you very much, Gillian and Holly, for hosting, and thank you everyone for attending. The next Innovation Lab webinar is on the 27th of August, and it's going to be hosted by Toby from Crew Energy, and that is one of our Next Generation funded projects. So please come along if you can. There's the link to sign up for tickets, and I'll follow up this webinar with the recording and that link again, so you can sign up if you'd like to. So thank you very much, everybody.
Thank you.
Thank you.